Hello, Math 120, and this is Professor Gonzalez, and I'd like to go over some homework problems from 4.4. And so what we're looking at here, excuse me, is figuring out what the greatest common factor is, learning how to factor out the greatest common factor, and from that factor by grouping. So let's begin. The first thing you need to do is be able to identify what the heck a greatest common factor is. So if I take these two numbers and write them over here, so we have a little more space to operate. If I have 28x and I'm comparing that with 16. Now remember, factors, prime factorization is when you factor, let's say 16 down into 4 times 4, this factoring tree business you may remember from the past. That'd be prime factorization. We don't really have to prime factor it. I mean, you could do that, but I think at this stage of the game, you want to look at these two numbers, and you want to see, can I factor this down to having common factors where factors show up on both lists, and I want the greatest, the biggest, so that's the G part, the greatest common factor. So the biggest factor that I can see, let's start with a number. So what's the biggest number factor, numerical factor, with a 28 and a 16? And I think it's going to be 4, isn't it? 4 is the biggest factor, right? 28 divided by 4. And 4 is the biggest factor in 16. Now, what about the variable x? Well, there's an x here, but there is not an x over here, so we do not have a common x. So 4 is our greatest common factor. We'd be done. I'm going to go a step further just to show what are the remaining factors in here, just so we can see it. Well, it'd be 4 times what? Okay, 4 times 7 gives us 28, and there's still an x. And over here it'd be 4 times 4. So it's good to be able to know what remaining factors are still there for when you start factoring out the greatest common factor. Once again, on number 2, we want to figure out what is the greatest common factor. So I'm going to write out 16 x to the 5th, y to the 6th. Let's see. Then we had 12 x to the 2nd, y to the 5th. Then we had finally 20 x to the 3rd, y to the 4th. Once again, I'm going to, not yet, break these down to 2 factors, and I'm going to look for the largest factor. Let's start with a number. So in terms of a numerical factor, I can see 4 is common, right? There's a common 4. Yeah, with all of them, there is a common 4. So 4 is our biggest common numerical factor. Now, what about the variables? So x is definitely common. So we're looking for the greatest we can take out on each one. That makes people think it might be x to the 5th, but it has to be common to all. So x to the 5th, x to the 2nd, x to the 3rd, x to the 2nd is the greatest common to all. Right? At least have x times x on each one of those. So x to the 2nd is the greatest common factor in terms of the x base. Now let's take a look at y, and you'll see pretty quick that really the rule is you look at y to the 6th, y to the 5th, y to the 4th, you take the smallest power, and that's the one that's going to work for all in terms of a greatest common factor. What factors are left? They're not actually asking this question because they say, okay, we'll write down the answer. It's just going to greatest common factor is 4x squared y to the 4th. What is left? Because it is a good rule, good thing to practice. What factors are left? Well, 4 times 4 gives us that 16. X squared times x to the 3rd gives us our x to the 5th. And y to the 4th times y to the 2nd. Okay, so there it is. That's quite a bit. That's the remaining factors. How about this second term here? Well, 4 times 3 would give us 12. X squared is already x squared. Y to the 4th, we need one more to make y to the 5th. And how about the remaining last? I'm going to zoom in here because of space. We've got multiplied by 4 times 5 would actually give us 20. X to the 2nd, we need another x to make x to the 2nd, and one more makes x to the 3rd. And x to the 4th is already there. Okay, so far they didn't ask us to do that. They just asked us for the red greatest common factor. But now when we want to factor out the greatest common factor, we're going to need to know both pieces, the red and the black, to make this happen. So, and these are getting a little bit complicated, huh? So let me zoom in a little bit. So I've got 25 x y to the fifth minus 20x squared y to the second plus 35 x to the seventh y to the 10th. So what we need to do is we need to factor these guys down. We'll start with our red, looking for the greatest common numerical factor. 25, 20, and 35, I believe 5 is that going to be the greatest numerical factor that is common to all. Now x to the first, x to the second, x to the seventh, x to the first is the greatest I can take out of each one. And y to the fifth, right here, y to the second, y to the, whoa, what is that? Y to the 10th. I think I'm going to clean that up because I can't even tell what it is. I think I cleaned it up. So then in terms of the x's, what was x to the first was the largest, so that's it. And then I've got y to the fifth, y to the second, y to the 10th. Y to the second is the most I can take out. So there's your greatest common factor, which is 5, 5x y to the, I must have missed, did I miswrite something here? Darn. I see what happened. I didn't copy down the problem right. This is 25x y to the fifth. This is x squared y to the seventh, and I put a 2. That changes things a little bit, doesn't it? So it's x squared y to the seventh. 35x to the seventh y to the 10th. Okay, the rest is fine. So the only thing that I need to revise is my y. What's the most I can take out with y? Whoops, what's the most I can take out with y? Well, we got y to the fifth here, we've got y to the seventh, and y to the 10th. So the most I could take out of each is y to the fifth. Right, you understand what I'm saying? This particular one only has a y to the fifth. So you cannot take, so y to the fifth means y times y times y times y times y. 5 y's being multiplied. So you certainly couldn't take out 7 of them. They're not there. So that's why the lowest power is the most you could take out of all of them. Now, and that, like I said, screws people up a little bit because we said greatest and you're taking the smallest. And you're like, what is going on here? But I gave you my reasons. And anyhow, so let's see here. 5 times what gives us 25? So this must also be 5. And by the way, we have our greatest common factor. Let me answer that question. Greatest common factor is 5xy to the fifth. Okay, now we want to factor out the greatest common factor. And what they're doing here is, let's see, let me use some color to highlight. What I have in red, they already have in red right here. It's kind of hard to see what they're doing. But there it is right there. I need to make that a little smaller. That's very, very aggressive. Let's see. So there's that piece right there in red, right? And then this piece in red is right here. Gee, I can't see. Oh, here it is right here. And this piece in red is right here. Okay, so you can see that's what they have here. So now we need to complete the remaining factors, and that's why we went through. That's why we're doing that right now. So 5 times 5 is 25. X y to the fifth. All right, that's it. So that's just one remaining factor, and they gave that to us. There it is right there. So they just gave that one to us. Okay, now the next one. Now make sure your signs match up. See, this negative sign is right there. Okay, now we have 5 times 4 gives me 20. X to the first times another x would give me x to the second. Y to the fifth times y to the second would give me y to the seventh. So this remaining factors would be 4x y to the second. Once again, plus, plus. There's this piece, there's this piece. What's remaining? 5 times what gives me 35? That's going to be a 7. X times what gives me x to the 7th? Well, I need x to the 6th. Y to the 5th times, I need another y to the 5th to make y to the 10th. And so these remaining factors must be 7x to the 6th, y to the 5th. Oof, a lot going on there. So 4x, y to the 2nd, and then we have 7x to the 6th, y to the 5th. So what is the final answer when you factor out the greatest common factor? Once again, I'm going to use my color here to show that we factored out this greatest common factor, which shows up out in the front. And then what's left is the stuff in black, which would be, here's a 5, right? I got mine up there, 5. And then it was minus, and then it was 4x, y to the 2nd, and then we had plus the last remaining factors in the last term, which was 7x to the 6th, y to the 5th. Whew, there's a lot going on there. And how do you check it? They checked it for us, but essentially the way you check this thing is you distribute that factor you factored out, the greatest common factor, you distribute it to each term and combine like terms, and you better have what you started with over here. And they did it for us, and yes, that is true. Okay, so let's take something much easier. Okay, let's start with number 4, which is going to be easier. So number 4 says factor out the greatest common factor. So essentially what we have here is I've got some space here. Let me write number 4. Let me do that again. Write number 4, and we have 3a minus 15. Now when we're looking at common factors, let's start with numerical common factors, which would be 3. It's definitely common on both of those terms. What is remaining though? Well, there's an a here and there's not an a there, so that's not going to be common. So now we have 3 times a is 3a, and 3 times 5 gives us that 15. So we can see pretty clearly using this color that 3 is the greatest common factor, and when we factor that out, the remaining factors are just going to be a minus 5. Now we can't add a's and 5s, they're unlike terms, so we just leave it like that, and that is the finished product or finished end of our problem. Let me fix that a up a little bit. Okay, let's do another one. Now, one general rule, a rule that's true is you can always factor out 1 as a greatest, and that wouldn't be the greatest common factor, but you could always factor out a 1, and you could always factor out a negative 1. Now, to factor out a negative 1, the only reason why we might do that is because if there's a leading negative value. So that's kind of a preference thing, right? So that's something that we often like to do that because it kind of cleans up the problem and it's kind of a good standard. Even though the math of the two answers, if you factor out a negative or not factor out a negative, mathematically they're going to be the same as long as you did your math properly. But it's more of a convenience thing that we say we see a negative as a leading coefficient. Let's factor that out. Okay, so that's what we'll do. So we have negative 7a minus 21, and we're looking for the greatest common factor, and since that leading negative is there, let's factor it out. So we're going to go ahead and take out a negative 7 as a leading, as a greatest common factor. We look at our variable a, and we don't have any value there over here, right? So a is not going to be a greatest common factor. And something to be careful with the signs, you have to remember that that when you put these two signs together down here, so if I'm going to use a plus symbol here, which would be probably convenient, a positive times a negative is still going to give us this negative. So that has to still gel or jive or whatever you want to say. So negative 7 times a is negative 7a, so that works. And negative 7 times 3 is negative 21, so that works. So our greatest common factor, since we decided to factor out the negative 7, which does make it slightly more complicated, gives us a binomial of a, what's left? A plus 3. And factoring out a negative is always a little bit disturbing in some ways of the signs. So you could always check it quickly by using the distributive property. What is negative 7 times a? Negative 7a. So far, so good. What is negative 7 times 3? Negative 21. Perfect. Okay, it is the same thing, so I know I factored it out correctly. That doesn't guarantee that you factored out the greatest common factor, but it does check that you factored out a factor or the greatest common factor, but you did it correctly. The factoring out was correct. You might not have gotten all of it, the greatest, but it's a pretty good check. Okay, so number 6 is these two guys. Let me write this down in a black pen. Let me see how much space I need here. I think I can fit that right up here. So 35x squared minus 15x. We're looking for that greatest common factor. And we're going to do that in red. In terms of the numbers, I believe 5 is common. In terms of x, I've got x squared and x to the first. So x to the first is the most I can factor out of either one of those. What do I have left? Well, 5 times 7 gives me the 35. And x times x gives me x squared minus, and then 5x times 3 gives me that 15x, and of course our sign is matching up perfectly there. So we factor out our 5x, and we have left in black inside our parentheses 7x minus 3. So 5x times the quantity 7x minus 3. Let's take a look at another one. Next one here is going to be, 2x cubed plus 14x squared minus 10x. Looking for our greatest common numerical factor. I'm thinking it's 2. How about a variable? I got x cubed, x squared, and x. So x is the largest amount that I could take out of any one of those terms. And let's just see what is left in terms of factors. 2x, well, there's still an x squared to make x cubed. And 2x, there's still 2 times 7 to make the 14, and x times x to make that x squared. 2 times 5 to make that 10, and that's it. We already have 1x. The signs are just going to come down. And now we factored out the greatest common factor as 2x. What is left inside this trinomial should be x squared plus 7x minus 5. So 2x times the quantity x squared plus 7x minus 5. Let's take a look at the next one, and we've got a negative leading coefficient, which is a little bit of a bummer because we're going on the technique that we're going to factor out the negative then in that case. So what is this? This is going to be a negative 5. Let's go like this. Negative 5, negative 5x to the 4th plus 50x cubed. And then minus 50x squared. If I copied that down correctly. Negative 5x to the 4th plus 50x cubed minus 50x squared. Good. So we go ahead and do our little factoring here. We use our color to look for the greatest common factor. Because that's a negative 5, we're going to take the negative out. And this does get a little bit tricky. Okay. How about x's? X to the 4th, x to the 3rd, x to the 2nd is the most that we can actually take out of each. And let's go ahead and see what remaining factors are there. X squared to get x to the 4th. Well, we're going to need another x squared. What about the sign? Well, these two signs, how is that negative going to become a positive? The only way that does is if that's negative, right? So That has to be true. Look at this. Negative, the red negative times the black negative, negative times negative makes a positive. So there's the tricky part. We're going to go ahead and use the distributive property to make sure we've got this right. Okay. And what about this one right here? Well, a positive times a negative gives us a negative, so that's going to work. Okay, now let's see, what do we have here? We have 5 times, oops, lost my, 5 times 10, right? 5 times 10 is going to give us that 50, and the x squared times x. So that's what we have there. Let's see, how about this one? Now notice we got the signs taken care of, so don't worry about the signs. Now we've got 5 times 10 is 50, and then we already have the x squared. So let's see, and we're going to want to check this one because, like I said, it's always a little dicey when you're factoring out negatives. And you get really good at, you can do this in your head, but it's still, not a bad thing to check because it's easy to drop a negative. So we've got in red, we've got our negative 5x squared, and then we've got what's left inside is x in black, x squared. Take the sign right there, x squared minus 10x, take the sign there, plus 10. Okay, we can certainly go ahead and go back and distribute that negative 5x squared to double check. Let me get the green color to kind of do that. Negative 5x squared times x squared is negative 5x to the fourth. Negative 5 times negative 10 is positive 50. And x squared and x is x cubed, so that's the whole thing. And then negative 5 times a positive 10 gives me negative 50. And then I've got that x squared. So yeah, it does. It checks out perfect. Okay, the next skill that we want to do is something called factoring by grouping. So I think I want to do this one on the side. Let me do this one, and then we'll go through do the step through. The step through, I'm not always a big fan of the step through, but like I said, I always like to have something for you to go back to. But let me do this one on my extra sheet of paper. I think I got an extra sheet of paper on the bottom. Nope, I don't. But I can make one. Supposedly if you continue to draw, they'll give you another sheet. There we go. But then that's in my way. I feel like I gotta clean that up. So let's make it, if I get rid of it, it'll all disappear. There we go. But the page will disappear if I get rid of that whole green thing. So I got that tiny little green guy right there, keeping this page. It's weird, I don't know. Anyways, that's how iPads work. So anyways, we're down here, and I would like to do problem number 9, and then we'll go up and do their fill in the blank part of this. But 6w squared plus 5w minus 24w minus 20. 6w squared plus 5w minus 24w minus 20. So I like to do this because I've got this whole routine that I go through. I've been doing this for a long time. And what we've been doing is trying to factor out the greatest common factor. So if you try to do that here, look at the numbers. 6, 5, there's nothing in common there in terms of their factors. So that doesn't work. And you look at the w's, oh, w's common, w's common, w's common. No w. So w's are not common with all 4 terms. So our greatest common factor is not going to happen. So some very smart mathematician did something different, which seems almost like they're breaking the rules, but they're not breaking the rules. But let's see what they do. They must have thought, well, how about if I just factor, how about if I look for a greatest common factor with just 2? Now this goes nowhere unless something happens. Let's see what happens here. So what's common? Well, a w is common. So I'm going to factor out a w. And what that leaves me with is, I'll do it in red. And by the way, you could actually divide out w in your head, which would give you the same, which is factoring, dividing and factoring are very similar because they're the opposite of multiplication, right? So if we factor out a w, and the reason why I did that because we got a common w there and a w to the first, we're left with 6w plus 5, right? If you distribute that out, you'll find that that's correct. Now, the next thing is I'm gonna use some logic here, and you don't know this yet, but it turns out if I could get the same exact binomial factor, right? I know it's two numbers, so it's kind of confusing. But if I could get the same binomial factor, I will have had a common factor. So question to you. What times 6w could possibly make a negative 24w? And if you said a negative 4, I think you might be onto something. Let's see. Let's go ahead and use our little green check. Negative 4 times 6w is negative 24w. And negative 4 times a positive 5 is negative 20. So that does check. Now, the next step is kind of a mind, kind of messes with our mind. But let me just for a second, if this problem was w minus 4 and you had like this big, let's just use the variable g for my last name. Let's say that was the problem. What would you say the common factor is? Oh, you'd say, oh, they both have g's, so we can factor out a g, and we would be left with w minus 4. We're essentially going to do that, but instead of a g, we're going to have what? This nasty binomial that is our common factor that must factor out. So you see what's going to happen here. Let me get rid of this stuff. What's going to happen here, instead of g factoring out like the last problem, what factors out? This nasty binomial, which is 6w plus 5. You're like, whoa, we just factored a problem that didn't have greatest common factors with all terms, but it ended up having a greatest common factor after we factored by grouping with two terms. And since those are common, they get to factor out, right? They get to factor out. And you might say, well, that doesn't look the same, and I don't believe it's the same. Well, we could always convince ourselves by doing this extended multiplication, some people like to call FOIL. 6w times w is 6w squared. 6w times a negative 4 is negative 24w. And then keep it going. 5 times w is 5w. And 5 times negative 4 is minus 20. Is that the same thing I started with? Yep. And, well, it changed its order, but I took the sign with it, so it's not a problem. Yep, that is the same thing. Those are the same. So what we just found out is, even though not all 4 terms have a greatest common factor, if you're able to factor out a greatest common factor as a group, then you can factor that, and that's called factoring by grouping. Let's do the same problem as they do the problem in a step-by-step fashion. Let's see if I can do this. Step number 1, okay. Group terms with common factors in this problem. The first 2 terms have a common factor of what? So, let's see here. So it says, okay, let me just read that. I got distracted a little bit. Group the terms with common factors. In this problem, the first 2 terms have a common factor of what? The first 2, and that's what I just did, right? So the first 2 have a common factor of w. Remember that? We did that on our own. The first 2 had a common factor of, whoops, let me do it this way, black, which left us with 6w plus 5. So, in this problem, the first 2 terms have a common factor of w, and the last two terms is going to be this guy, and the last 2 terms have a common factor of, what was it? Well, it could be negative 4, but in this problem, remember how we wanted this to be the same, 6w plus 5. We kind of had to figure out what factors out to make that happen. And remember, we did that on the problem I just did. Happened to be a negative 4. So negative 4 times 6w is negative 24, and negative 4 times 5 is negative 20. So this second one would be negative 4. Okay, and then so they verified it down here. So then the next step, we factored out, and I got to use the same color now. We factored out a w, which left us with 6w plus 5. We factored out a negative 4, which left us with 6w plus 5. And this procedure only works if you can make those two binomials identical, right? And those two binomials are identical, which means, right, which means they can factor out right there. Then you got to realize what is left. What is left is your w minus 4. And there you go. And they check it for us. They say 6w plus 5 times the quantity of w minus 4. And we end up getting the original problem, just like I did. Okay, so number 10, factor the following expression by grouping. Can we do it? Let's see. Let me write it down. 3w squared plus 2w minus 12w minus 8. You might ask the question, do we have to rearrange things? And on some problems you do, but mostly in this class you don't. So if you first said, okay, let me group the first two. Usually it works. If it doesn't work, you could rearrange the problems a little bit. Like, this one could go there and this could go there and try it out. But for the most part, on most of these problems we do in this class, they work as long as you know the procedure. You take pre-calc and you get into tougher ones that don't work, or you have to rearrange them. And there might be a couple in the book, but it doesn't happen much in this book. Anyhow, we look at the first two and what is in common. Not the 3 and the 2, definitely w. What is left after you factor out that w? Well, we're left with 3w plus 2. Now I'm telling you, for this procedure to work, factoring by grouping, I have to have a matching 3w plus 2. So I'm just going to write it down. If I can't make it happen, then the problem doesn't work anyways. So now I ask, what times 3w gives me this negative 12w? And that's going to be negative 4. So negative 4 times 3w is negative 12w, and negative 4 times 2 is negative 8. So perfect. It worked. Now you can see that I have my common factors right here, and those can be factored out. And so I'm going to factor those out, and that becomes 3w plus 2. And then what do I have left? In black, I've got w minus 4. So there we go. And by the way, the order that you write this down in terms of the binomials, let me just flip it around just so you can see I can. It's totally legal because multiplication is, whoops, I just lost my sign there. Multiplication is commutative, so that means that you could change the order. Don't change the w and the, dang it, just lost stuff. So you can change the product. So let me show you. W minus 4 times 3w plus 2 is just as good as writing it this way. Doesn't matter. Look at the next one. The next one we have w squared minus 2w plus 5w minus 10. Let's take a look at the first two and just see if it works. What's common? W. So we factor out a common w, and what are we left with? A w minus 2. Of course, you could always distribute it to make sure that that's true, and it is true. And then the next problem, what is common? So I'm looking at these two terms, and I see a common 5. So I factor out a 5. And what's left inside? W minus 2. Once again, these must match. They have to be common factors for this technique to work. So then we factor out our w minus 2, and what's left is our other binomial. Gets multiplied by w plus 5. Factoring by grouping. There you go. Number 12. Number 12, it says, I'm going to copy it down, 2x squared minus 12x minus 4x plus 24. What's a common factor? Numerically 2. How about x? Factor out of 2x, what do you have left? Well, x minus 6, right? Distributed 2x times x, 2x squared. 2x times negative 6 is negative 12. Yes, that did work. Now, I'm going to go ahead and do that technique that I often do, especially when there's negatives involved. We know, okay, the next two that we need to factor out is to take a look at the remaining two binomials, or remaining two terms rather. And we know that we have to get this same matching x minus 6 for this to work. So the question is, what can you factor out? What can you factor out to make this 4x? Well, negative 4. Negative 4 times x is negative 4x, and negative 4 times negative 6 is our positive 24. So that worked beautifully. So now we see that we have our common factors, right? Are these two nice common factors which come out. And that becomes x minus 6 are the common factors. We're allowed to cancel, factor out common factors. And what's left is 2x minus 4. Factor by grouping, keep it going. Okay, this is 3x cubed plus 18x squared minus 12x squared minus 72x. Let's look at the first two terms. I'm seeing that 3 is common and x squared is common. So what is left in the parentheses must be x plus 3 times 6 is 18, and we already have it x squared. So this, if in order for this to work, I must factor it down to that common factor. And let's see if I can do that. Well, negative 12x times x is our negative 12x squared. And negative 12x times 6 is our negative 72x. So it worked. So now we're going to factor out the common factor, which was x plus 6. And what's left, and I'm going to put it over here this time just to show that I can. It doesn't matter if you put it on the right or the left. It's multiplication. 3x squared, whoops, 3x squared minus 12x. Now you might get that and you feel all happy and good, and then you put it in and it says you got it wrong. Now you're mad, right? Well, I'd be a little mad too. But the thing is, you're missing something. This is going to be factor by grouping, and you have to factor completely. Completely. And the problem here is, will anything factor anymore is the question. Are there any more common factors? And when I look at this, let me use another color. I do see a common, not that. I do see a common 3, right? There's definitely a common 3 in 12. And also I see a common x. So it turns out that this thing is the problem that keeps on going. Sometimes that happens, where I can see that there's more common factors within just that black binomial. Turns out 3x can be factored out, which leaves me with x minus 4. Once again, distributed to double check, 3x times x is 3x squared. 3x times a negative 4 is negative 12x. And of course, this is still here. Don't let that drop off. It's part of the answer. Now we have factored. This is factored, but this is factored completely. So usually that's always what we do. Factor completely. Okay. If you can factor out more, factor out more. This problem right here is like if someone said factor completely, let's say 12, and you said, okay, 12 factors down to 3 times 4, and someone says, oh, wait a minute, no, completely, 3 times, and 4 factors down to 2 times 2. So really what you're doing is you're prime factoring with this stuff. You factor till you can factor no more, which means you're factoring down to prime factors, except these are binomials instead of 3 times 2 times 2. But the idea is the same. So let's take a look at number 14, factor by grouping completely, to make sure you know. Now this says 9y squared plus 7y minus 81y minus 63. Look at the first two terms and let's see what we can factor out. Certainly not 9 and 7, but a y is going to go. And what do we have left is, I don't want to say it goes, it factors out. And what we have left is 9y plus 7. 9y plus 7. Now I'm going to write down, I have to get a 9y plus 7 for this procedure to work. So I'm just going to kind of assume it, but if it doesn't work, I just cross the whole thing out. Now what times 9y is going to give me negative 81y? How about negative 9, right? Negative 9 times 9y is negative 81y. Negative 9 times 7 is negative 63. Perfect. And so therefore, we factor out the common factor, the red stuff, 9y plus 7. And then we have what's left is our y minus 9. And we factored it completely. Take a look at the next one, the next problem. We'll write right here, which is x cubed plus x squared plus 14x plus 14. Look at the first two terms. Factor out an x squared, the greatest common factor of just those two terms. What is left? X plus 1. We have to get an x plus 1 for this to work. So we just assume that temporarily and say what times x gives me 14x? Well, this better be 14 times x is 14x, and 14 times 1 is 14. So that worked out beautifully. And now we're going to go for the finished product, or the finished answer. And our common factors factor out to x plus 1. And then what do we have left is our x squared plus 14. Now that, after that last problem where we had to actually factor more and it wasn't complete, this one might get you going saying, can I factor that more? Well, there's no greatest common factor. And next section, we're going to take a look at, special products, binomial special products, which will help us identify that. But this one's prime, so it's done. And number 16 is our last problem. So number 16 is already sort of grouped for us. And most students that first start a problem like this, the mistake they make, because we're going to factor the polynomial completely, and the mistake they make is they start multiplying everything. And although that might work out in this case, let's see, you're going to square. Yeah, you still could do it that way, but you're just making a big mess out of it. And in some cases, by multiplying a polynomial, you could turn something into a third or fourth or fifth powered polynomial, which is going to be really hard to factor. So there's something already kind of nice going on here, and I think you can see it. Notice that is to the first power, and that is to the second power. But they are common factors. In fact, here, I just had an idea. Let me write them out more, I guess, explicitly. This one says y times the quantity y minus 2, and there's only one of them. And this says y minus 5 times the quantity y minus 2, but there are two of them. Okay, so I think I just got a brainstorm all of a sudden. Okay, so how about if I write it like that? Now you can see, oh, darn it, I hate it when it does that. Now you can see that there's a common one there, and there's a common one there. There's only one common one over here. So you can only take out one common one, just like when you have, x to the first and x to the second, you could take out only one x to the first because that's as much as this term has. So we factor out that common y minus 2, right? And then what do we have left? What do we have left? We're going to have, we're going to have left is a y plus, let me get rid of that sign under it, plus I have a 5 still, and I still have a y minus 2. Well, if I could simplify, I have to simplify, and I do see some simplification here. How about 5 times y, distribution 5y, and 5 times a negative 2 is negative 10, and these guys are like terms. I still got my parentheses. Y plus 5y is 6y minus 10. Oh boy, I can see this is going to be the problem that does not quit. We still have this guy out here. But notice there's a common 2. So you must factor out 2. What are we left with? 3y minus 5. And don't forget this guy right here. Usually we like to have our monomials out front. So I'm going to sneak this one back over here. even though it wouldn't be wrong if you put that in front. But we like our little monomials out in front. That's just a not really a hard fast rule. Okay, I hope that helped out. We covered a lot there. Factoring the greatest common factor, figuring out what a greatest common factor is, factoring it out, and factoring by grouping. Okay, have a great day. Goodbye.